Welcome to the last section of Chapter 7, double angle and half angle formulas. So here in the first box, we have the double angle formulas. For sine 2 theta, there's just one version, but for cosine 2 theta, notice we have 3 different variations. I'm just going to quickly show you how to derive the double angle formula, so hopefully it makes more sense. So for sine 2 theta, we're going to use our angle addition formula. That's sine theta plus theta, right? Isn't that 2 theta? And then using our angle addition formula, this would be sine theta cos theta plus cos theta sine theta. But these are really just like terms, right? Sine theta, cosine theta. So we have 2 sine theta cosine theta. So there's that one. Now what about the double angle formula for cosine? Well, same idea. You derive it using the angle addition formula. So cosine of 2 theta is cosine of theta plus theta. And remember, cosine's formula is cosine theta and then cosine theta minus sine theta times sine theta. So this is where we get cosine squared theta minus sine squared theta, which is the first one that you see here. Now notice there's 2 other versions, and that comes from just substituting in 1 minus sine squared for cosine squared, or 1 minus cosine squared for sine squared. So I'll show you another version. So I'm going to replace cosine squared theta with 1 minus sine squared theta, and then I still have the other minus sine squared theta, and guess what? That gives us 1 minus 2 sine squared theta. Okay. And then similarly, if you were to replace the sine squared in the original, you would get 2 cosine squared theta minus 1. So I'll let you work on that. What I recommend if you're memorizing these, for sure memorize the sine double angle, because there's only one version. And then for cosine 2 theta, as long as you know cosine squared theta minus sine squared theta, you can derive the other 2 if you need them. All right? Tangent 2 theta. Same thing, let's derive it really quickly. So that's tangent of theta plus theta. And so remember our formula is tan A tan B, so tan theta plus tan theta over 1 minus tan A tan B, so that's 1 minus tan theta. And that's where we get 2 tan theta over 1 minus tan squared theta. So that one you can easily see how it falls into place. All right, and then the last new formulas are the half angle formulas. So sine of alpha over 2 equals plus or minus, and this plus or minus is dependent on which quadrant alpha over 2 lives in, so you'll have to determine that. Plus or minus the radical of 1 minus cosine alpha, all divided by 2, and that 2 is underneath the radical. And then the only difference for the cosine half angle formula is it has a plus. So I just think, oh, when it's cosine, because it matches, it's plus. And for sine, since it's cosine in the numerator and it doesn't match, it's a minus. Okay. Now this version here of the tangent half angle formula comes from just taking sine of alpha over 2 divided by cosine alpha over 2. Honestly, it's pretty ugly. I don't recommend using it. Most of the time, I would use one of the versions here, boxed number 13, that comes from rationalizing the denominator. And if you're going to pick one to stick with, right, because there's so many versions to memorize, I would memorize this one. Why? Because there's only one term in the denominator, so it's going to be easier to rationalize the denominator for this version of the formula instead of the other one. If you had 1 plus cosine alpha and you had a rad in there, then you'd have to multiply by the conjugate, where if you just have sine alpha, it's going to be an easier one. But it's up to you. I mean, they'll all work. That's the beautiful thing about math. Okay, so let's move on to some examples. You just got to put these all to memory as soon as possible, and they do come up a bunch in calculus 2 especially, so don't forget them. All right. So use the information about the given angle, alpha, or theta in this case. Theta is between 0 and 2 pi, to find the exact value of the following. So we're going to find A, B, C, and D for each of these 2 problems. So this is basically like problem 1, problem 2. So the first thing for problem 1, they tell me tangent of alpha is 1/2, and alpha, or why do I keep saying that? Theta is between pi and 3 pi over 2. Okay, so if theta is between pi and 3 pi over 2, that means theta lives in quadrant 3. Now, I'm going to figure out where theta over 2 lives. So theta over 2 is going to be between 3 pi over 4 and pi over 2. So if theta is between 3 pi over 4 and pi over 2, then theta over 2 is in quadrant 2. So let's draw a triangle here. So my triangle is for theta, right? They gave me information on theta, and that I know is in quadrant 3. So I'll label it accordingly. So here's my quadrant 3 triangle. I want it perfect. Okay. Here's theta. Tangent is positive 1/2, but I know that's going to be a negative and a negative since we're in quadrant 3. So this side here is rad 5. All right, so the first thing we're going to compute is sine 2 theta. Well, that's 2 sine theta cosine theta, which means I have 2 times, well, sine of theta, that's going to be opposite over hypotenuse, so negative 1 over rad 5. Cosine is going to be negative 2 over rad 5. And then multiplying the numerators, I'm going to get positive 4 rad 5 times rad 5 is 5. All right. Part B, cosine 2 theta. We can just use cosine squared theta minus sine squared theta. That's always my go-to. So this is going to be, cosine is negative 2 over rad 5. We square it, minus sine is negative 1 over rad 5. We square it. If I square negative 2 over rad 5, it's going to become positive 4 over 5. Minus squaring negative 1 over rad 5 is going to make it a positive 1/5. And I end up with 3 over 5. Okay, so far so good. Now parts C and D require us to work with the half angle formulas. So C, sine of theta over 2 is going to equal plus or minus the square root of 1 minus cosine theta, all divided by 2. I really recommend writing out the formula before you plug all the quantities in. It's just going to help you memorize it more quickly. All right, so let's decide. If I know theta over 2 is in quadrant 2, is sine of theta over 2 going to be positive or negative? We're over here. Y values are positive there. So I'm going to choose the positive sign, okay? So I don't need to write plus or minus anymore. I'm choosing the positive radical. And I'm going to have 1 minus, now cosine of theta is negative 2 over rad 5. And then this is all divided by 2. Okay, so let's clean up a little bit. This is going to be the square root. I have 1 plus 2 over rad 5 over 2. And now I want to rationalize the denominator and get rid of that radical. Okay, so the first thing I'm going to do is multiply by rad 5, so I don't have a fraction within the numerator. Okay, so now we have the square root. This is going to be rad 5 plus 2 over 2 rad 5. But then notice I have a radical in the denominator, so I want to get rid of that. So I'm going to multiply by rad 5, and then I have to do the same thing up here in the numerator. And then my final answer, yeah, this is the final answer. So if I distribute rad 5 times rad 5, that's 5, plus I have a 2 rad 5 over 2 rad 5 times rad 5 is 2 times 5, which is going to be 10. Okay. So that's it. I know we have a radical underneath another radical, but there's really nothing to do to get rid of it. So you're just going to have to live with it. Just make sure you don't have a complex fraction, meaning you don't have a fraction within the numerator or denominator, and make sure you don't have any radicals in the denominator besides the big one that's there, okay? Last part is cosine of theta over 2. So we have plus or minus the square root of 1 plus cosine theta over 2. So now let's decide. We're in quadrant 2, right? Theta over 2 is in quadrant 2. So is cosine positive or negative over here? Well, the x values are negative, which means cosine is going to be negative. So this time I'm going to choose the minus sign. And then this is going to be negative radical 1 plus negative 2 over rad 5, so that's 1 minus 2 over rad 5 over 2. And then if you notice and compare with when we were working on the same thing for sine theta over 2, it's basically identical. I just have subtraction in the numerator instead of addition. So we can save ourselves some time and just alter the last result that we got. Just keep the negative on the outside. Oop. We have rad. And then this is going to be 5 minus 2 rad 5 over 10. Okay. So simplifying those half angles can be a little tricky. So just be patient. If you need to review some of your rules for radicals, that's totally normal. All right, moving on. We have secant of theta equals 2. And cosecant of theta is less than 0. So saying secant of theta equals 2 is equivalent to saying cosine of theta equals 1/2, right? And then they also tell me cosecant of theta is negative, which is the same as saying sine of theta is negative. So if cosine's positive and sine is negative, that means theta is in quadrant 4. And you know what, guys? I actually know what theta is. Theta is 5 pi over 3, but I'm going to pretend like we don't know that because we want to practice using the formulas. All right, so if theta, let's separate our work. If theta is in quadrant 4, that means theta is between 2 pi and 3 pi over 2, which means theta over 2 is going to be between pi and 3 pi over 4. So which quadrant is that? That's quadrant 2. All right, good. Now let's work through the parts of the problem. So we have, we can draw a triangle, why not? I guess we don't need to because we know exactly what theta is, but let's not cheat because they gave us a nice angle. So theta is in quadrant 4. Here's x, here's y. And here's theta. And secant is 2. Cosine is 1/2. So here's the adjacent side. Here's the hypotenuse. And there's the opposite side. Okay. Now let's get to work. So A, sine of 2 theta is equal to 2 sine theta cosine theta. So that's going to be 2 times, well, sine theta, that's going to be opposite over hypotenuse. So negative rad 3 over 2 times cosine theta, which is 1/2. And then notice the 2 and the 1/2 cancel. So I just get negative rad 3 over 2. And you could have checked that that was correct because we know exactly what theta is. So you could check that sine of 2 times 5 pi over 3, so 10 pi over 3, that should give you the same thing. That would be equivalent to sine of 4 pi over 3. All right, part B, cosine 2 theta equals cosine squared theta minus sine squared theta. So cosine of theta, that's going to be 1/2 squared minus negative rad 3 over 2 squared, which gives us 1/4 minus 3/4, which is negative 1/2. All right, so far so good. Now for the half angle formula. So part C, sine of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 2. Now let's think. We determined that theta over 2 is in quadrant 2. So is sine positive or negative there? Well, the y values are positive in quadrant 2. So I'm going to choose the positive rad. So I'm going to have the square root of 1 minus, now cosine of theta, that's 1/2 over 2. So I have the square root of 1/2 over 2, which is the same thing as square root of 1/4, which is 1/2. This one was a lot easier to simplify than the last example. And then part D now needs cosine of theta over 2. So we have plus or minus the square root of 1 plus cosine theta over 2. Now remember, theta over 2 is in quadrant 2. So this time I'm going to choose the negative. Okay, so we're going to have negative radical 1 plus cosine theta, so 1 plus 1/2 over 2. So that's negative square root of 1 plus 1/2, that's 3/2 over 2. So that's negative rad 3 over 4, which is negative rad 3 over 2. Does this make sense? Remember, we knew for this problem, okay, this was a special kind of fluke problem, that theta was 5 pi over 3, which means that theta over 2 would be half of that, which is 5 pi over 6. Do we know what cosine of 5 pi over 6 is? I mean, you should. It's negative rad 3 over 2, right? So you can make sure that you applied the formula correctly for this example, but typically it's going to be for angles that you wouldn't be able to just directly evaluate. All right. On to some more examples. We've been neglecting tangent, so it's his turn now. So use the half angle formula to find the exact value of the expression tangent of 9 pi over 8. Well, 9 pi over 8 is not one of the angles, right, that we know from our unit circle. We don't know the sine, cosine, or tangent of it, but I do know double that angle, don't I? 9 pi over 4, I do know. And if I divide 9 pi over 4 by 2, then I get 9 pi over 8. So that's why I'm going to use the half angle formula. So the version for tangent that I recommended is 1 minus cosine of theta, so cosine of 9 pi over 4, over sine of 9 pi over 4. Now remember, 9 pi over 4 is larger than 2 pi. So if I subtract 2 pi, which is 8 pi over 4, I get pi over 4. So that means 9 pi over 4 and pi over 4 are coterminal. So they'll have the same values for sine, cosine, tangent on the unit circle. So in my head, I'm just going to think of 1 minus cosine of pi over 4 over sine of pi over 4. All right, so this is going to be 1 minus, now cosine pi over 4 is rad 2 over 2 over rad 2 over 2. What do we need to do first? Well, we have a complex fraction because we have a fraction within a fraction, so that's a no-no. So I'm going to multiply everything by the LCD. I'm going to multiply by 2. And I get 2 minus rad 2 over rad 2. Is this okay? No, I can't have a radical in the denominator, so I'm going to multiply by rad 2 so I can rationalize the denominator. And now that's going to distribute up here. So we'll have 2 rad 2 minus rad 2 times rad 2 is 2 over 2. And then I can simplify and basically cancel out that 2 and get rad 2 minus 1. Okay. Did anyone notice a faster way we could have gotten there? Let me show you something for fun. Or at this step right here, okay, when we have 2 minus rad 2 over rad 2, you could split the denominator and just write it as 2 over rad 2 minus rad 2 over rad 2. Well, what's 2 divided by rad 2? Think of it this way. We know rad x times rad x is x. So if you have x over rad x, that's rad x. So this is just going to give me rad 2, and this is 1. I think that's faster, but not everyone sees that, so it's okay. All right, so that's it for applications. Now we're just going to work on an identity or two. So establish each identity. First one, example A, cotangent of 2 theta equals 1/2 times cotangent of theta minus tangent theta. All right, well, I noticed that on the left-hand side, I have a double angle, so I can go ahead and use a double angle formula and then hope that when I work with it, it'll give me the right-hand side. So I say let's start with the left-hand side. So cotangent of 2 theta, I did not give you a formula for cotangent of 2 theta, and that's because it's just 1 over tangent 2 theta. So you can take the double angle formula for tangent and use its reciprocal for cotangent 2 theta. So that means 2 tan theta is going to be in the denominator, and 1 minus tan squared theta is going to be in the numerator. All right. Okay, now I noticed here on the right-hand side, you have to use it for inspiration, okay? See how there's 2 terms? So that's motivating me to split the 2 terms in the numerator over the denominator. So I'm going to write this as 1 over 2 tan theta minus tan squared theta over 2 tan theta. Did you see that? So it's totally normal to look to the other side of the equation, your goal to inspire your next move. Okay, well, we're pretty much there, right? If I have tan theta in the denominator, I can rewrite this as 1/2 times cotangent theta. And then one of these tangents is going to cancel out. I'm going to write 1/2 instead of over 2, a la the goal over here. So minus 1/2 tan theta. And then it looks like we're done. I just got to factor out that 1/2. And then we have cotangent theta minus tan theta. And that is the right-hand side. Okay. Lovely. Next one, example B. Sine squared theta cosine squared theta equals 1/8 times 1 minus cosine 4 theta. All right. Well, I noticed there's a 4 theta here, so we can maybe play around with a double angle. And you might say, what do you mean a double angle? I see a 4, not a 2. Well, this is how we're going to think of it. Cosine 4 theta is the same as cosine of 2 times 2 theta. Don't you agree? So we're going to apply the double angle formula, but I'm going to have a 2 theta everywhere theta normally goes. So we're starting with the right-hand side this time. And we have 1/8 times 1 minus. So using the cosine double angle formula, I'm going to have cosine squared. Now this time it's 2 theta minus sine squared 2 theta. All right, since I had a 4 theta to begin with. Okay, and then now I'm looking at this 1, and he needs to go away, right? So maybe I'm going to replace this with a 1 minus sine squared 2 theta, so I can cancel it with the 1. So I have 1/8 times 1 minus, this is going to get replaced with 1 minus sine squared. Now make sure you match the argument. This needs to be a 2 theta, same exact angle that we had, minus sine squared 2 theta. Okay, and so these ones are going to cancel out, and then now I have 2 sine squared 2 thetas, right? Because the negative is going to distribute. So I have 1/8 times 2 sine squared 2 theta. 1/8 times 2, that's 1/4. And then instead of writing sine squared 2 theta that way, I'm going to write it as sine 2 theta squared, right? It means the same thing. And I feel good about where I'm going because look, the arguments here are just theta and theta. So I've worked my way down. We had a 4 theta, now I only have 2 theta. Now I'm going to use a double angle again so I can get everything to just be in terms of theta. So we have 1/4. Remember the sine double angle formula? It's going to be 2 sine theta cosine theta squared. And then remember that exponent distributes to everything inside the parentheses. So the 2 gets squared, the sine gets squared, and the cosine gets squared. So I'm going to have 1/4 times 4 times sine squared theta cosine squared theta. And voila! The 1/4 and the 4 cancel, and we have sine squared theta cosine squared theta, which is the left-hand side. All right, very nice. So those take practice and patience, but eventually they become super fun. All right, last 2 examples are solving equations. So solve each equation on the interval 0 to 2 pi. So first thing you have to keep in mind is that you don't want to have mixed arguments, meaning you don't want to have an equation where you have a 2 theta and a theta. That's going to be really problematic. We've solved equations in the previous section that had 2 theta in them, but not while there was a trig function of theta at the same time. Okay, you can only have one or the other. So let's use a double angle formula. How convenient. I'm going to replace cosine 2 theta with cosine squared theta minus sine squared theta. And then this equals 2 minus 2 sine squared theta. All right. And then it'll be a lot easier if instead I switch this cosine squared theta to 1 minus sine squared theta so that everything's in terms of sine squared, right? So if this is 1 minus sine squared theta, then I still have the other sine squared theta, negative, equals 2 minus 2 sine squared theta. So this is 1 minus 2 sine squared theta equals 2 minus 2 sine squared theta. And do you notice something? Well, the negative 2 sine squared thetas cancel out, and I end up with 1 equals 2. Well, this is a false statement, right? 1 doesn't equal 2, so there's no solution to this equation. End of story. No solution. If you want to write that symbol, that means the empty set, okay? Or you can write an actual literal empty set. This is real. I didn't make it up. Okay, or the word no solution will suffice. All right, that wasn't very satisfying. I don't like it when I don't get a solution, usually. So let's do another one. Sine 2 theta equals cosine theta. So first thing, let's use our double angle identity. So this is going to be 2 sine theta cosine theta equals cosine theta. And then what do we do from here? Divide by cosine theta? No way, that's super illegal in math. You do not divide by a variable or by some sort of function of a variable. So you're gonna subtract cosine theta over to the other side, okay? And then we're gonna have 2 sine theta cosine theta minus cosine theta equals 0. Now I can factor out a cosine theta, and I have 2 sine theta minus 1 as my other factor. So I'm going to apply the zero product property and set each of the factors equal to 0. If you had divided by cosine illegally, then you wouldn't have any of the solutions from this equation. You'd be missing so much. So either cosine theta equals 0 or sine theta equals 1/2. So let's think. Now the problem asked for solutions between 0 and 2 pi only. Okay, so when is cosine 0? Well, that's when theta is pi over 2 or 3 pi over 2. And then when is sine 1/2? Well, that's when theta is pi over 6 or 5 pi over 6. So our complete solution set is going to include all 4 of those, pi over 2, 3 pi over 2, pi over 6, and 5 pi over 6. Well done. So that concludes section 7.6, and this is the last lecture from chapter 7.